Betelgeuse is a gigantic red supergiant, situated in the constellation of Orion. It has enchanted people for centuries with its intense crimson radiance and enormous size. Astronomers have estimated that should Betelgeuse be situated at the heart of our solar system, it would devour all planets up to Jupiter. This star's vastness signifies that it is getting close to the end of its lifespan, a phase that typically culminates in a catastrophic explosion now known as a supernova in recent years. However, Betelgeuse has exhibited extraordinarily unusual behavior. Its brightness increased by more than 50%, catapulting it from the 10th to the 7th brightest star in the night sky. This unexpected flare of brightness left scientists scrambling for answers. Was this a warning sign of its explosive death, or just a brief blip in its life cycle? The potential effects are enormous. If Betelgeuse were to go supernova, it could brighten the night sky to the point where day and night would seem to rotate, creating exceptional opportunities for science. A star's size affects its brightness, temperature, and proximity to Earth. Betelgeuse, with a diameter greater than 700 times that of the Sun, is relatively cooler. With surface temperatures around 3000 Kelvin, this gives it its signature red hue. Its size, combined with its low temperature, makes it a prime candidate for a supernova. In 2019, Betelgeuse stunned astronomers again by dimming to just 40% of its typical brightness, a significant shift. Visible even without telescopes, prompted widespread discussion and observation. Some considered the possibility that dust had obscured the star, while others examined internal processes within Betelgeuse. The possibility of a supernova occurring soon became a key topic among experts. Using the Very Large Telescope VLT in Chile, astronomers captured specific images of Betelgeuse during its dimming phase. These pictures demonstrated that the star had become clearly lopsided. The distorted appearance suggested further investigation. The dimming was likely caused by a massive mass ejection from the surface, which Betelgeuse released a remarkable quantity of material into space. This unprecedented event altered the star's appearance and slowed its pulsation cycle. The event was comparable to a cosmic-scale volcanic eruption, as Betelgeuse spewed out more than 400 billion tons of material, far more than typical solar events. This upheaval not only changed the star's appearance but also shortened its 400-day expansion period to just 200 days. These major changes indicate that Betelgeuse is becoming more unstable, leading to more questions. How much longer can it maintain its current form? Due to its erratic behavior, astronomers have intensified their monitoring efforts, eagerly looking for evidence of imminent collapse. When a massive star, like Betelgeuse, exhausts its nuclear fuel, the core breaks apart under its own weight, causing a supernova. This colossal explosion ejects a tremendous amount of energy, blasting the star's outer layers into space and producing a brilliant light show visible even during the day. If Betelgeuse bursts into flames, the first signal would be a small burst of neutrinos, subatomic particles that travel faster than light and can escape the star. These neutrinos would reach Earth hours before the light from the explosion itself. When the light finally appears, Betelgeuse could shine brighter than the full moon, casting eerie shadows and illuminating the night sky for weeks. A supernova of this magnitude would provide an unprecedented chance for scientists to investigate star death in real time. By analyzing the emitted light, heat, and radiation, researchers could gather essential data regarding nuclear physics, star formation, and the creation of life-essential elements. To understand Betelgeuse's unusual behavior, researchers are using sophisticated stellar simulation models. These virtual models include data from telescopes like the James Webb Space Telescope, JWST, and the VLT, allowing researchers to explore the mechanisms behind Betelgeuse's instability. Simulations suggest that a significant gas bubble may have formed deep within the star, altering the rhythm of its pulsation. JWST observations provided a closer look at the debris ejected by Betelgeuse, revealing complex structures of gas and dust surrounding the star. According to these findings, Betelgeuse may be entering the final stages of its life cycle, offering an unheard-of glimpse into the death of a massive star. while scientists predict that Betelgeuse might explode in space between 10,000 and 100,000 years from now. Its unpredictable behavior suggests the timeline could be much shorter. The astronomical community is racing to capture every aspect of this cosmic spectacle before it reaches its imminent climax, ensuring humanity doesn't miss this rare event. In late 2023, the JWST, with its unparalleled capabilities, focused on Betelgeuse and discovered astonishing new phenomena. Scientists found that the star, already unstable due to its massive surface ejection, had suffered an internal collapse. This collapse was indicated by significant changes in its fundamental dynamics, altering the flow of nuclear fusion reactions. Astronomers observed dramatic fluctuations in Betelgeuse's expansion cycles before the collapse. The star's surface had been contracting and expanding steadily for over 400 days, a rhythm abruptly shortened to just 200 days, indicating a major disruption. In the star's internal structure, these irregularities acted like a cosmic heartbeat, signaling that Betelgeuse might be nearing the end of its life as a red supergiant. Simulations conducted by astrophysicists revealed that the star's core is becoming increasingly unstable. As it fuses heavier elements, Betelgeuse begins to produce iron, a phase that marks the final stage before collapse. Unlike other elements, fusing iron does not release energy, causing a buildup of mass that ultimately forces the core to collapse. Betelgeuse's recent behavior has sparked heated debates among astronomers about the timeline of its supernova. While some argue the explosion could occur within the next few centuries, others believe it may still be tens of thousands of years away. However, it is evident that the era of Betelgeuse as a red supergiant is coming to an end. One of the key indicators of an impending supernova is a surge in neutrino activity, tiny subatomic particles that break away from a star's core moments before its collapse. Scientists are keeping a very close eye on Betelgeuse for all of us. Sudden spikes in neutrino activity and the tools in its vicinity have put the world on high alert to detect this fleeting signal, which could provide humanity with its first real-time warning of an impending supernova. While the supernova in Betelgeuse will be an incredible, inspiring, cosmic event that can even be seen during the day, scientists assure us that although it poses no threat to Earth, its brightness could compete with the full moon, creating enigmatic shadows and illuminating the night sky for weeks. This event will not only captivate stargazers, but also offer an unprecedented chance for researchers to examine stellar death in real time. The tale of Betelgeuse serves as a reminder that there are still many mysteries in the universe waiting to be discovered. This enormous star, which has captivated humankind for centuries, continues to challenge our understanding of stellar evolution. Betelgeuse's surprising cosmic dynamics, its dimming, mass ejections, and unpredictable behavior serve as a reminder of how much we still have to learn. Its potential to go supernova offers scientists an extraordinary opportunity to study the life cycle of massive stars firsthand. Understanding these processes goes beyond unraveling the fate of one star. It's about unlocking the mechanisms that shape galaxies, seed the universe with vital elements, and even make life possible. This information enhances our comprehension of the universe's history and our place within it. The tools we use to study Betelgeuse, from ground-based telescopes such as the Very Large Telescope to cutting-edge instruments like the James Webb Space Telescope, have opened new windows into the cosmos that previous generations could only dream of. These technologies enable us to conduct simulations, investigate the motion of stars, and peer billions of years into the past to gain a deeper understanding of the foundations of reality. For scientists like Neil deGrasse Tyson, discoveries like these create a sense of urgency and excitement. They push the limits of human understanding and encourage us to continue exploring the cosmos. The next time you look up at Orion's belt, remember that one of those points of light tells the story of a star on the brink of its destiny. What do you think will happen to Betelgeuse? Are we witnessing the final stages of a star about to explode, or is this just another phase in its mysterious life cycle? Voice your opinions and join the conversation about one of the most intriguing stars in the universe. Don't forget to like, subscribe, and turn on notifications for more cosmic stories that will inspire you to keep looking up. As we continue to observe Betelgeuse and its behavior, it becomes clear that this star is not merely a fleeting presence in the night sky. Its unusual activity is providing astronomers with rare opportunities to learn about the intricate processes that govern the evolution of massive stars. Every change in brightness, surface mass ejection, and abrupt shift in pulsation patterns brings us closer to understanding the mechanics of stellar life cycles. One of the most intriguing aspects of Betelgeuse's evolution is that it is currently in a relatively rare stage of its life as a red supergiant nearing the end of its existence. However, the journey to becoming a supernova isn't as straightforward as it may seem. The specific causes behind Betelgeuse's irregular behavior are still being debated by scientists. While surface mass ejection is one of the most dramatic indicators, it could mark the beginning of a more complex series of changes that ultimately led to the star's collapse. Equally fascinating is the idea that Betelgeuse's supernova could help answer some of the biggest questions in astrophysics. The explosive death of a star, like Betelgeuse, holds the potential to reveal secrets about the nature of dark matter, the expansion of the universe, and the processes that lead to the formation of new stars and planets. These revelations may assist scientists in improving existing models of the cosmos and gaining a deeper understanding of the universe's evolution over billions of years. Research based on Betelgeuse is part of a broader global effort by astronomers to comprehend the life cycles of massive stars. Stars like Betelgeuse help scientists study the final stages of stellar evolution, which are notoriously difficult to monitor. In real time, stars die in extraordinary ways. They are often distant and hard to observe, so when a star like Betelgeuse begins to show signs of its final explosion, it provides an exceptional opportunity to observe this cosmic process up close. One unanswered question remains: how long before Betelgeuse actually reaches the supernova stage? The star's ultimate demise remains a mystery, and scientists are constantly adjusting their predictions based on new information. Some astronomers believe Betelgeuse could explode sooner than expected, while others think it may take thousands of years, regardless of the timeline. The excitement surrounding the star's eventual explosion continues to grow. For now, researchers are closely monitoring Betelgeuse using a range of advanced instruments from ground-based observatories like the VLT-2 space telescopes like the JWST. They are using the latest technology to peer more deeply into this massive star than ever before. The data they collect will help improve our understanding of stellar evolution and offer new insights into the forces that drive the universe itself. As Betelgeuse's story unfolds, it serves as a powerful reminder of the vastness and complexity of the cosmos. Many stars in the universe are undergoing astonishing transformations, but few offer as clear a look into the final stages of stellar life as Betelgeuse does. Its impending supernova will be a monumental event, one that could help scientists answer some of the most profound questions about the nature of stars, galaxies, and the universe as a whole. While we may not yet know exactly when Betelgeuse will explode, one thing is certain: its death will be a significant event in the study of stellar evolution for astronomers and scientists. It is a global phenomenon, one that presents countless opportunities for discovery and advancement in our understanding of the cosmos, and for the rest of us, it will serve as a powerful reminder of the incredible mystery and beauty of the universe we inhabit.